Hello friends, myself Reena Jarwal from Shri Digambar Institute of Technology, Dausa. Today I discuss about the topic of signal flow graph. So let us start. First of all, the question that is generated in our mind is that what is signal flow graph? So signal flow graph is a diagram that is represent a set of equation. Generally can say that a signal flow graph is a combination of nodes and branch. So basically we can say that signal flow graph is used for complicated system because the block diagram reduction technique that is used in last class for calculating transfer function is completely wastes the time and space. So reducing the disadvantage of block diagram technique, we use SFG, that is signal flow graph. In signal flow graph, nodes and branches are connected to each other to perform a calculating a transfer function. So next, the comparison of block diagram and SFG. In last lecture we discussed about the block diagram. In block diagram we reduce a block from a new block. So multiple times we redraw the block. So because of this wastage of time and space is very high. So reducing the disadvantage of block diagram, we perform signal flow graph. In signal flow graph, only one time a graph is drawn, and by the help of Mason-Gain formula we calculate the transfer function, and because of this time and space is saved. So in SFG we used nodes and branches. Generally nodes are represented by a dot, that is a point. Sometimes it is known as signals. It is represented by V of S, and the branch is represented by a directed line in which a arrow is represented, that is G of S. So here the definition of some terms that is used in SFG. So one by one we discuss about it. So first of all, node. Node generally is a point that is represent a variable. So here a diagram is present in which three nodes is represented, that is x1, x2 and x3. So we can say that for representing a variable we used node. Branch. What is branch? Generally when we join the two nodes by the help of a line is known as branch. So this is the branch. Next, input node. Generally input node has only outgoing branch. So in the diagram we see that x1 and x2. x1 has an outgoing branch, so x1 is the input node. Next, output node. Output node only contain a incoming branch, so sometime it is also known as sink node. So in the last diagram we see that about incoming node, input node, and this we see that x2. In x2 incoming branch is represented, so x2 is output node. What is mixed node? Mixed node has both incoming and outgoing branch. So mixed node is generally represented between the starting point and ending point. Now the question is, what is transmittance? So generally the gain between the two nodes is known as transmittance. Transmittance is generated and represented by T. So here between the node x1 is represented as T12, between the node x2 and x3 it is represented as T23, and between the node x3 and x4 it is represented by T34. So these are the transmittance. So these are the gain that is represented between the nodes, that is known as transmittance. So path. What is path? Generally the path is the traversal of connected branch in the direction of branch arrows. So we can say that generally the path is a traversing point between input to output. Now next, what is forward path? When a path is originate from starting point and terminate at ending point is known as forward path. So generally here we see that RS is starting from here, then forward to from G2 to G3, then G4, and output is terminated at here. So this is the forward path. Now the question is generated in our mind is that what is forward path gain? So the forward path gain is the product of branch transmittance of a forward path. So basically the transmittance between the starting point to ending point is represented by a gain. So these are the forward path gain. Now next, what is loop? When the path that is originate and terminate at the same node is known as loop. So here G1 is starting from here and it is terminate also here. So this is the loop. So we can say that the path that originate and terminate at the same node is known as loop. What is loop gain? Generally loop gain is the product of branch transmittance of a loop. So the branch transmittance is represented by a loop gain. Now what is non-touching loop? Generally non-touching loop is a loop that don't have any common node. So here L1, L2 and L3, these are non-touching to each other. So these are non-touching loops. Now representation of SFG terms. So here we see that X1 and X3 is worked as X1 is worked as input node and X3 is worked as output node, and the node that is between the starting and ending point is known as mixed node. Here some transmittance is also represent, that is A, B, C and D, and this is the forward path loop that is represented here, and the line that is represented by a direct line with an arrow is known as branch. So these are the representation of SFG terms. So here it is represent. Now rules for drawing SFG from block diagram. So these are the rules. So first of all, in block diagram we discuss about summing point and takeoff point. So when summing point and takeoff point is represented in block diagram and it is converted into SFG, then summing point and takeoff point is represented by a node, that is a point. And if a summing point is placed before a takeoff point, then the takeoff point shall be represented by a single node, same as summing point. And if a summing point is placed after a takeoff point, then the takeoff point and summing point is represented by a different nodes. Next, in starting we study about Mason-Gain formula. So what is Mason-Gain formula? Generally Mason-Gain formula is used for calculating the transfer function. So here the formula is that G of S is equals to C of S upon R of S, that is summation of K, P of K, del K upon del. Here Pk is represent the forward path gain, del K is represent the 1 minus loop gain which does not touch the forward path, and del is represented as 1 minus summation of loop gain plus summation of non-touching loop gain taken 2 at a time minus summation non-touching loop gain taken 3 at time plus so on. And K is the number of forward path. So by the help of Mason-Gain formula, we calculate transfer function easily. So we can say that signal flow graph is used to reduce the disadvantage of block diagram technique and calculate the transfer function easily by a single graph. So thank you.